Ready?
Yeah.
All right, so I'm excited. Looking at your given, remember when you have given information, you always want to go through and see if there's any explicit congruencies. There's not. Okay. So then you want to look at the things that they're hiding behind the given information. That's why they give you the given. They have to provide you some information. Okay. But in that information, there's going to be a lot of hidden stuff. Okay. And what becomes important for you is if you don't know your definition, you don't know your theorems, you don't know your corollaries and your postulates, all those phrases that we've talked about, that hidden stuff is going to stay hidden from you. Okay. You can only bring those pieces of information out by knowledge of those properties, statements. Okay, so the first thing we need to pay attention to, I guess, would be the vocabulary here, right? Going left to right, there are two vocabulary words. Do you agree with that? And it doesn't matter which one you look at first, but I'm going to look at perpendicular. Okay, what types of things? If I were to look in the back of the book, perpendicular lines create what? Cameron?
Right angles.
Right angles. Okay. So for us, we want to look at the problem. Okay. And identify what those right angles would be. Okay. So looking at our problem, our right angles are going to be. Let me move this stuff around a little bit. All right, our right angles would be what? ABD. Angle ABD. And angle CBD, right? We're going to say they are right angles. That is the only information that you can get from the word perpendicular. Okay, now what's the relationship about two right angles? They're congruent. Okay, so I'm going to write here definition of perpendicular lines. That's how I knew I had right angles. Okay. But once you develop right angles, you then make the argument that ABD is congruent to angle CBD. And our reason, if you remember, we had a theorem that said all right angles are congruent. All right angles are congruent. All right? Huh? Uh-huh. Now, I know some of you are saying, well, why do we have to take 2 steps to do that? Okay? We had to do 2 steps here because I look at those 2 statements and I say right away, off of the fact that the lines are perpendicular, I know instantly, yes, those 2 angles that I develop are going to be congruent. Okay? But in my proof, I have to be more deliberate and specific with my statements because of my reasons. Okay? When I want to say number 2, if I wanted to incorrectly do this proof, I wanted to jump straight from perpendicular to basically ABD being congruent to CBD, our reason would have to be because definition of perpendicular lines provides right angles, and we know that right angles are congruent. Does that make sense? So the reason that we need 2 separate statements over here is because if I just made statement number 3, okay, and I didn't have that thing, this reason here would have to be both of those things anyways. Does that make sense, everyone? So you have to be deliberate. You can't kind of assume that the person that's reading your work knows everything that you know. Okay? You hear the phrase all the time, say what you mean and mean what you say, right? So we want to be able to do that. We want to be very specific with what we're saying. So the person that is reading our work knows what we mean. Okay? So let me kind of undo some of that stuff I just drew all over there. So now you have a congruency. You have information in your picture that is useful. That angle is congruent to that angle. Whenever you develop a congruency, always draw that back into your picture. Okay. What is the other vocab word that is in our given? Midpoint. Okay? Midpoint of AC. All right? So if we look in the glossary, midpoint tells us we get 2 segments that are what to one another? Equal or congruent, right? So for us, those two segments would be what? If we're bisect, or sorry, have a midpoint of AC. Careful. AB and CB or BC, I want to name. So AB is going to be congruent to BC because of the definition of a midpoint. All right, so hopefully you guys understand that when we have a definition, definitions are written in respect to general cases. Okay? When we have a picture and a proof, we have specific cases. We have a segment AC. The definition just says it's a general segment. So the definition of midpoint says it takes a segment, divides it into two smaller congruent segments. Well, we have specifically in this problem two smaller segments, AB and BC. So I want to refer to them by their names. Okay? So we've exhausted all vocabulary words, right? And that's what you want to do. Every time you do a proof, go through every single vocabulary word in your given and write down what it means to you. As you go through and you create new statements, if you introduce new vocabulary words, you have to tell what those new vocabulary words do for you. Okay? We didn't introduce any new vocabulary words here. So we're done with the given information. And when you're done with that, you always want to come over to the picture. And what is one thing that we know about that picture that's going to be useful? Good. So BD, is that what you're going to say, Cameron?
I was going to say AB and CD are equal.
Say again.
AB and CD are equal.
How? If you're going to say that, you've got to have a reason to tell me that you know they're equal. Reflexive is something is equal to itself. And AD and DC are not the same thing, right? They're not themselves. Like AD is not, when I say AD is congruent to AD, that's the reflexive property. When I say DC is congruent to DC, that's the reflexive property. But AD congruent to DC is not the reflexive property. So you have to tell me why you would know those two segments to be congruent. And we really don't have the tools to be able to do that. The only way, this becomes very important. You might want to write this down, maybe at the top of your page or in your notes or whatever. The only way that we can tell segments are congruent, we've got three techniques. First technique is really easy. It's the reflexive property. Okay, that is the number one easiest way to determine that segments are congruent. And it's a segment congruent to itself. All right. So BD is congruent to BD is what we're saying. That's the reflexive property. That's the easiest way to ever show segments congruent. Okay. The second way we've already done in this proof. The second way that we can determine whether segments are congruent is through the use of a midpoint. Okay, midpoints always provide congruent segments, and we saw that in step 3 there. Okay, or not step 3, sorry, step 4. So that's the second easiest way to show segments congruent. And when I say midpoint, that kind of encapsulates the idea of if they ever tell you have a segment bisector. So this question could have said, DB is a segment bisector. Well, if I understand my definitions of segment bisectors, a component of a segment bisector is that it's going through a midpoint of another segment. So segment bisectors kind of lead us to midpoints as well. Okay, so those are maybe the easiest ways to show segments congruent. The other way to show segments congruent is through the segment addition postulate and doing some algebra with segments, and that's somewhat troublesome sometimes. So we won't see that until maybe next week. Okay. But right now, if you want to show segments congruent, the only way you're going to do it is reflexive property or midpoint. Okay. So if I wanted to show AD and DC congruent, as we're working through this proof, they don't have a midpoint, right? They have to have a midpoint. They have to be collinear points. They have to be the same segment. Okay. Or collectively, the entire thing would have to be one collinear segment. And we don't have that existing with AD and DC. There's a corner there, right? There's a bend. And obviously the reflexive property doesn't exist for those. Okay? Now, if I go to my picture and draw that in, if I show BD is congruent to itself, how many parts do you have labeled or identified in your picture on the left triangle? The left triangle has 3 segments and 3 angles, right? There's 6 total parts. How many of those parts do you have? Do you have 2 of them marked? Do you have 3 of them marked? 4 of them? How many of the 6 objects up there in that left triangle do you have a marking on? 3. Okay? You've marked 3. You've marked the bottom segment, you've marked the right segment, and then you've marked this angle, right? So you got 3 things marked here. And that's what we always want when we name triangles congruent. Okay? We have to have 3 things marked over here, 3 things marked over here. So we need 3 congruencies. What that tells me is that there's 3 congruencies existing inside here. Okay, inside my statements. So I have enough to show triangles are congruent. So I'm going to say triangle ABC is congruent to triangle. Okay, now if I named it ABC, going off what we learned earlier in the week, how do I have to name that second one? Oh, I'm sorry. That's a D up there, isn't it? I'm sorry. ABD. ABD. A to B. CBD. This is D up here. So I gotta go CBD. Good. CBD. And the important, so that's side angle side, because that's the relationship of these parts, right? That's the 3 parts that we identified are in that order in both triangles of side, angle, and then a side. Okay, so the angle is sandwiched in both triangles. The reason we had to name those that way is because our goal is to prove segments congruent. Okay, not necessarily to prove triangles congruent. So every time you get to this stage here, in this chapter, and really in the next chapter, the following chapter, once you prove triangles congruent, you want to take that and you want to match it up to the proved statement. And if they're identical, then you're done. If they're not identical, you probably have one more step to go. Okay? So if I look at proving AD and CD, I'm going to come down to my picture. Or not my picture, but my statement down here. I'm going to find AD in this shape here. Okay? It's the first letter and the last letter, right? So CD better be the first letter and the last letter over there. And that's verification that I do know that they match. So what's another word for matching? Corresponding. They came from what types of triangles? Congruent triangles. So corresponding parts that come from congruent triangles are themselves what? Congruent. So AD is congruent to CD. And walking you through that phrase that we were talking about is corresponding parts of congruent triangles are congruent. Okay. As you do these proofs, my hope is that you start to feel comfortable with them. Okay. Usually a triangle congruency proof, I would say the amount of steps. We'll see one here in a little bit. That's 10 steps if we forget a previous theorem. It's like 4 steps if we remember a previous theorem. But the proving triangles congruent is usually 5 to 6 to maybe 7 steps. Okay. If you're trying to prove triangles congruent, you're up to 13 steps. You're doing too much. Okay. You probably overlooked something, or you don't know the process well. If you're proving things triangles congruent in 1 step or 2 steps, you're missing some stuff. Okay. So we're looking in the ballpark between 4 to 7 steps when we're doing these. But you need to make sure that you have your congruencies, your 3 congruencies that you're looking for to use one of these statements. Somebody in the last class said, could I have taken this statement here, this statement number 5, and could that have came somewhere else? Okay? And I think about BD congruent to BD. Is there anything above that statement that impacts it? That it depends on? Okay? No, that statement is all by itself. It's an independent statement. And you could put it anywhere you want to. It could even come before the given if you wanted to. You could have put that statement right there, could have gone there, could have gone right there, could have gone right there, and obviously could have gone where it went. Okay? But it is independent. Okay? The reflexive property usually is independent. Okay? Of anything else that's existing. However, statement 6 cannot show up anywhere you want it to be. That cannot be statement 2. Because statement 6 depends, because it's side angle side, right? So it depends that we show those 3 parts congruent. So it has to come after those 3 arguments. Okay? Does that make sense? Alright. The argument that, I know this is getting kind of messy here with all my markings on here, but this argument here, that angle is congruent to angle CBD. ABD is your angle CBD. That statement is dependent on that one, that they're both right angles, right? So they could not be flip-flopped. However, statement 3 could move down further in the proof if we wanted to. Statement 3 could have came here, or it could have came there, okay? As long as it comes after the black one up here, and it comes before the triangle being congruent. So as you're doing these proofs, yours might be a little bit different than your neighbor's, it might be a little bit different than mine, but if we understand the idea of what statements are being impacted by others, okay, we should be able to kind of jostle our statements around a little bit and still come up with the same proof, okay, or the same truth statement. That's another reason why I like to use those 7 steps that I gave you early on in chapter 2, because if we go through vocabulary, statement by statement, and write down what that means to us, and exhaust all our vocabulary, if everybody does that, then chances are, I would think probably 95% of the time, your proof is going to match your neighbor's proof. Okay? And I think that just makes it a little easier in regards to consistency for learning how to do these things as we move on throughout the course. The older you get, the more you deal with this stuff,